everyone, welcome to Unit 3 of the third module in the online Geomatics and Geospatial NVQJ Level 2 program tutorial video. My name is Carrie-Ann Harriott. In this tutorial video, we will be showing you how to develop spreadsheets for geospatial data. By the end of this video, you should be able to create spreadsheets, use trigonometrical formulas to convert from one coordinate system to another, and to link worksheets to create a scatterplot diagram. The employability skills to be covered include use of technology, problem solving, and time management. Throughout the video, we'll be showing you tutorial tips that will assist you in remembering the steps. Are you ready? Let's get started. For our first exercise, we will create a blank Excel spreadsheet, then start adding values in our rows and columns. In our first column, we will add E for eastings, N for northings, and H for height. This will represent our JD69 coordinates, which is a spatial reference used in Jamaica. In the eastings row, type the figure as shown on screen, and do the same for the northings and the height. Good job! Now that we've created our spreadsheets and added our values, we will now add our transformation values.
We also add our transformation values. These values are imperative in datum transformation. In other words, these trig functions are to be solved in order to successfully convert spatial data from one reference system to another. Upon adding our transformation values, we add our output values, which in our case is degrees, minutes, and seconds, or latitude and longitude, another spatial reference system widely used.
This exercise is to simply show you how to calculate our output and how to solve the data transformational values. For example, the notepad text shown on screen is demonstrating how we use radian values using a trigonometrical function or trigonometrical formula.
In order to calculate our output, we must solve the datum transformation values. In this case, we are pretty much calculating radian values using a trigonometrical function or a trigonometrical formula. This formula was created as a means of calculating Jamaican coordinates through what's referred to as the Molodensky approach. Once we calculate our radians, we will convert this to decimal of degree and break this down a bit further into degrees, minutes, and seconds.
Now, let's add some colors and borders to our spreadsheet. To achieve this, we select Design and select from the various table styles displayed. For our next exercise, we'll be linking our worksheets. Let's get started.
Step 1. Copy the degrees, minutes, and seconds from one worksheet to another. Step 2. Paste the values in the first row. Take note that when pasting, select Paste Special and then choose the fifth option that says Paste Link. Please note that if any value changes in your first worksheet, it will also change on the second worksheet as well.
I also use this opportunity to convert my degrees, minutes, and seconds back to decimal of degree. You can see the link formula here in action. So if my value in sheet A changes, then my value here in sheet B will change as well.
For our next exercise, we'll create a scatterplot graph. The purpose of a scatterplot graph is to show how strong the relationship or correlation between two variables are. Let us now insert our scatterplot graph.
Step 1. Create a graph by selecting the Insert tab and choosing the option that says Scatter Graph. Here, we will use the latitude and longitude value information to create our scatterplot diagram.
This type of detail can be added to reports.
This concludes our tutorial exercise. Today, we learned how to develop spreadsheets for geospatial data. In our lesson, we learned how to create spreadsheets, use trigonometrical formulas to convert from one coordinate system to another, and to link worksheets to create a scatterplot graph. We hope you found this tutorial informative. Thanks again for watching. I am Carrie Ann Harriott, and see you next time.